Use tables, graphs, and symbolic representations to compare and contrast the maximum and minimum values of f of x equals 1 half times the absolute value of x minus 3 plus 2, g of x equals negative 1 half times x minus 3 squared plus 2, and h of x equals negative 1 half times the square root of x minus 3 plus 2. Okay, so first looking at f of x, we see this is an absolute value graph, and it does extend up on each side and then coming down to its vertex, and so it will be a minimum since that's the lowest value of the graph, and we see that that's at y equals 2, and the vertex is 3, 2. So we'll just note here that that's a minimum with min for short here, and then with our g of x, then that's our parabola, and I like to think of minimums as valleys. It's the lowest, and then the maximum will be like a mountain. It's going to be the highest point. And so g of x, we see that it is the highest point, the vertex, on the graph. And so again, it is still 3, 2, but here we can note that it is a maximum. And then on our square root function, we see it starts at its endpoint is also 3, 2, and then it continues downward, and so it is also a maximum here for h of x. And they all have the same point in common, but only the absolute value has the minimum, and then the other two have maximum. So then looking at our table, we can see here that, again, they all have 3, 2 in common, but looking at f of x, we see that it continues to go up as x gets either smaller or bigger, that y values go up. So it makes sense that it would be a minimum value because it goes up on each side of that. And then the other ones we both said were max. So let's see if that's true. So looking at the y values, we see it does go down on both sides, that the y values decrease. And then the last one, it doesn't even exist on one side because it's a square root graph, but it does go down on the other. So far it does show the same things as our graph did. So now let's just go ahead and prove these algebraically as well.